Desalination and Brackish Water. The future of drinking water? Rivers and lakes are currently sources of water for many cities. As climate change threatens access to current fresh water sources, new sources of water need to be found. Groundwater is 98% of fresh water found on Earth. That's 60 times more of that than surface water, like water found in lakes and rivers. As less water becomes available from lakes and rivers, some possible new water sources contain brackish water, which is water that contains higher levels of salt. In order to use this water, we use desalination. The desalination process uses reverse osmosis, which removes the salt and other compounds to give us fresh water. Reverse osmosis uses a semi-permeable membrane, which only allows water molecules to go through the membrane. The membrane is a filter that removes particles larger than the water molecules. Desalination can be costly because the reverse osmosis membranes are expensive. Currently, the city of El Paso, Texas, uses a desalination plant to get some of its drinking water. But we have an issue: sand. Sand can also be called silicon dioxide or silica. The silica can be larger particles like those found in sand or dirt or in quartz, or tiny little nanoparticles called colloidal silica, which are less than 10 nanometers. Colloidal silica can cause scaling, which clogs the reverse osmosis membranes, making the desalination process even more expensive. So, how can we remove these tiny particles of silica? With electrocoagulation. Electrocoagulation uses electrodes made of metals like aluminum or magnesium and runs electricity through the water with those electrodes to make hydroxides. These metal hydroxides have areas on the compound that adhere or stick to the colloidal silica particles. This removes the silica from the water, which causes less scaling. Yay! The less scaling there is, the longer the membranes can be used. This brings down the cost of desalination and increases the water produced. Electrocoagulation can have small capital costs, which is the money used to create the new electrocoagulation system, and small operating costs, which is money used to run the actual electrocoagulation system, making electrocoagulation a viable solution to deal with silica scaling. Depending on the metal used, the possibility of revenue, money earned, can make electrocoagulation pay for itself. Magnesium hydroxides can potentially be recovered, purified, and sold. Also, finding the optimal combination of electrical current, which is the flow of electrical charge through the water, and time for running the electrocoagulation system can lead to an even cheaper process. The Center for Inland Desalination Systems, SIDS, new Nano-Enabled Water Treatment Engineering Research Center, and the University of Texas at El Paso are currently working to see what the most cost-effective method for electrocoagulation is when used to improve desalination.